In this section, we will explore the meaning of radian angles. So what are radian measures and how do they compare to degree measures that we may already be familiar with? Well, a radian measure is simply another way of describing the measure of an angle of a circle. Radian measures are based on the radius of the circle. And in fact, if the length of a radius is picked up and it's wrapped around the circle, then the angle that's formed at the center of the circle by this arc is equal to what we call 1 radian. If this radius continues to wrap itself around the circle, it will take 3 full lengths with 0.14 left over to fill half of that circle. Now, 3.14 is equivalent to pi. So what this means is that half a circular rotation is equal to pi radians, and that a full circular rotation is equal to 2 pi radians. Now, what does that mean in terms of radians and degrees? Well, we now know that 2 pi radians is equal to that full rotation. We also know that 360 degrees gives us a full rotation around a circle. Now, if I divide both sides of that equivalency by 2, then I could rewrite this as saying that pi radians is equal to 180 degrees. And I could go even one step further. How many degrees is 1 radian? Well, if I divide pi radians by pi, then I'll have 1 radian. But if I do that on the left, I have to also do that on the right. So now I can say that 1 radian is equal to 180 degrees divided by pi. Remember, pi is about 3.14. And when I divide that, I get that 1 radian is approximately 57.3 degrees, which it looks like in this picture. So let's take a look at a few specific examples. In this first example, a radius of 1 is being wrapped around the circle, creating a length of 1 on the arc of the circle. Now this length is what is called an arc length and is being defined as the variable s, and is the length of the curve along the arc of a circle. Therefore, like we saw on the previous example, this angle measure is 1 radian. Likewise, if the radius changes to 2 and that radius of 2 is wrapped around the circle, we create an arc length of length 2, and notice that it says that theta is equal to 1, theta being the angle measure, and the 1 being the number of radians. Now, if the radius changes to 3, that pattern continues. The radius of 3 is wrapped around the circle, creating an arc length of 3, and theta is still equal to 1. Notice that although the radian measures here are all the same, that clearly the circumferences of each circle are not. As a refresher, what is the circumference? The circumference of a circle is simply the arc length of a full circle and has the formula c equals 2 times pi times the radius. For this first circle, when r was equal to 1, we would say that this circle had a circumference of 2 times pi times 1, or 2 pi. That's approximately 6.28. For the second circle that had a radius of 2, we would say that that circumference is 2 times pi times 2, or 4 pi, so twice as big. For the third, same pattern continues. We would have a radius of 3, so the circumference is 6 pi. What this confirms is that even though the circumferences of the circles may change, that the ratio of the circumference to the radius measure does not change. And that's evident by the fact that all of these thetas are equal to 1. So, in fact, c, which equals 2 pi r, can also be written as c over r equals 2 pi. This value of 2 pi is what we saw in the previous example, where a full circular rotation was equal to 2 pi radians. Now, if we're only interested in the arc length of a portion of the circle, then replacing the circumference with the variable s to represent arc length, s, and keeping the r, we know that s over r is going to equal some angle measure that we can call theta radians. We now have radian measure defined and can formalize it as follows. The radian measure of an angle is the ratio of the length of the arc subtended by the angle to the radius of the circle. In other words, if S is the length of an arc of a circle and R is the radius of the circle, then the central angle theta containing that arc measures S over R radians. If theta is equal to S over R, then arc length, which is S, is equal to R times that theta. When the measure of a central angle of a circle that intercepts an arc S is equal in length to the radius R of that circle, then the measure of this angle is 1 radian. For more information on radians, you might check out this YouTube video that really goes into much more detail.